Hello, everyone. Welcome to Formula SAE Design Overview. Thank you for joining us today, and a special thanks to the SAE Detroit section in partnership with the SAE Carolina section for hosting this event. My name is Edward Kasprzak. I'm president of EMK Vehicle Dynamics. I'm one of 3 chief design judges who will be presenting and moderating today. I will be giving an overview of the design event, focused on how the event is structured. Bill Riley, Vice President of Starship Engineering, SpaceX, and Tony Lyscio, Starlink Development Manager, SpaceX, will follow with a discussion of sound design practices and insights into how design judges view your car and team. Before we start, there are a couple of housekeeping items. All participants are automatically muted with their cameras off. We encourage you to use the chat function to ask questions at any time, starting now. We will take your questions and relay them to the presenter at the appropriate time. This presentation is being recorded and will be posted to the SAE Detroit section YouTube channel at a later date. All right, with the formalities out of the way, let's dig in. As mentioned, the first part of this presentation is an overview of the design event. So let's start with the big picture. The way design judges view this event is as an educational process. Okay, this is not motorsports, this is education. And so if you start to see the design event, in fact, the entire Formula SAE event from that perspective, then you'll get a lot more out of it in the first place, and you'll understand where some of the approaches, especially the design judges are taking, are coming from. Okay, our design judges are tasked to assess your knowledge, process, and understanding toward achieving the goals that you set. Okay, so what we care about here, first of all, is what's between your ears. Okay, your knowledge, your understanding, your process, your application of engineering to the problem. And if you notice the last part of that sentence, it says the goals you set. I'm not sure it's appreciated as much as it should be that our design judges are willing to follow whatever goals you say you think are the way to do best at the competition. And then what we do is we take your set of goals as a starting point, and then we see if you're following them throughout the rest of your design process into the implementation, the build of your car, and how you operate your car. For example, if you tell us that ultimate lightweight is the most important thing by far in the entire competition, we say, okay, now let's see how you followed that through. If you tell us, big horsepower, big downforce, big everything is the way to go to do the best in this competition, we say, okay, and we start there and we see how you do. You can't have a right engine or a wrong engine. You can't have, this short of violating engineering fundamentals. We're very happy to follow whatever your goals are and run with them. So there are no preferred sets of goals. And critically, judges are definitely not trying to pick the fastest car. We have dynamic events that do that. That is not our thing. Okay, I'd like to invite you to ask yourself, when does the design event begin? And the answer is on the next line. You should have said, well, it's about 6 weeks before the event starts when all of our design documents are submitted. Okay, and that is another place where I think students often don't appreciate what's actually going on here. Keep in mind that the judges have your documents for about 6 weeks. Okay, they get to talk to you for about an hour the first round of judging. And so most of the time we know you, it's from your documents. And occasionally we get feedback saying, oh, the judges seem like they had some preconceived ideas about us coming in. And like, well, they shouldn't have any preconceived conclusions. But I always point out, look, our design judges have done their homework. They've looked at all the documents you've submitted. They've gotten ideas of what to ask you about, things that look interesting, things they're not sure of. And so, yeah, they come in, they talk to you, not completely out of the blue. They've done their homework too. So they should have some idea where you're at based on your documents before you show up. Critically, do not be late submitting your documents. There's no reason at all. Documents can be submitted up to the deadline anytime. You can send them in a week in advance, a month in advance. You can submit them now if you wanted, quite frankly. We do have a trend where students tend to submit at the last day, hour, minute, less than a minute. No prizes for being closest to the deadline without going over. Okay, just get it in. Don't put yourself in a bad spot. Avoid getting yourself red flagged as, oh no, this seems already late. Why start off on the wrong foot? Basically. Okay, so let's talk about the design submissions for a few minutes. Our design briefing, PowerPoint-based document. There is a template to use. We ask you to respect the template because it lays things out in a common way for all teams so that our judges can actually find the information they're looking for. Think of it as the resume for your car and team. And critically, it is written for engineers. Okay, you do not have to tell us what a drag coefficient is or what acronym is or any of those terms. You can assume that we understand all those terms. Just run with it. Okay, provide an overview of your work. This is one of the things I like best about this format is you get to show a lot of your work. You can put in photos, you can put in drawings, charts, tables, calculations. Be concise, show what you did. What it does is it gives jumping off points for the judging discussion. Judges come into your team prepared to talk to you. They have things that they flag that say, oh, this looks really interesting. I want to know more about this. What did they do here? Why does this graph look that way? And that may be a good thing or not a good thing why your graph looks that way. We want to talk about those kinds of things. So yeah, show your work. You don't have to get wordy. This is not the place for sentences and paragraphs. The explanations will come when we talk to you. But put the information out there so that we have starting points to judge from. And as I mentioned earlier, state your goals. Not only state your goals, but compare how your goals relate to all the things that you did from there downstream. So I mentioned the template. There is a size limit for the number of pages and the file size. You definitely want to stick to that. Please do not change the structure of the template. What you see here on the right side of the screen is the separators, like on the bottom says suspension, maximum 8 pages. And make sure you leave a title slide that says suspension. You can change the background, put it in your school colors or whatever. You don't have to have the background that's on there. But don't change the skeleton of the template. Leave everything in the right places. Also, those little blue boxes you see in the upper of the 2 images, okay, those are spread throughout the template. Those are there as guides or hints to you. When you submit your final version, those should all have been deleted by you so that they don't make it through to the end. But they're there to help guide you along, let you know a little bit more about what we're looking for. As far as the other 2 submissions, we have the design spec sheet. Okay, that's an Excel spreadsheet-based document. Again, watch the template, please, especially your units, because every year we get somebody who tells us the wheelbase of their car is 62 millimeters. And yes, we know what you meant. That you probably, well, we think we know what you meant, that you were trying for 62 inches. But the specification in the spec sheet says millimeters, and don't mess with the units. Just put the right numbers in that go in the units that are given. We do it this way because we ask our judges to look at numerous schools. We want them to be able to find your information easily and have a reference. We all have numbers, ideas in our head of roughly what the right sizes are or what ranges we see. A number that sticks out will stick out. So just make sure you follow the units. And again, this is another case where you don't want to set yourself apart by being one of the 5 schools that has the wrong units in their spec sheet when there's 75 or 100 some schools in competition. We also are very aware that the values you submit in your spec sheet and those that you put into your design briefing are going to be a little bit different in some cases from the vehicle you actually bring to competition. After all, this is submitted ahead of time, at least 6 weeks before competition, hopefully a bit more. And so when you do get to competition, any discrepancies between the 2, please be ready to explain those. Okay. We understand that it happens, it's normal, it's not a problem. Just as long as you can explain, answer the questions that may come up, that's perfectly fine. As far as the 3-view drawings go, front, side, and top views. The image on this slide shows how we post some of the better ones every competition. We actually do find the best ones, the best 10-ish of these, and put them up somewhere so that students can get an idea of what a good drawing looks like. Okay. Please note, these are actual engineering drawings. They're not solid model renderings. They're not photos. We want an actual traditional style engineering drawing, top view drawing. And the last comment on any of these templates for the spec sheet or design briefing is to make sure every year you look for updates to the template. Yes, I know your car is an evolution of last year's car at some level, sometimes more, sometimes less. The documents, the templates are also an evolution of the previous year, but they do change. And so if you submit last year's spec sheet template or you miss an update in the design briefing template, that's another way you're going to stand out in a way you don't want to. So please check for those every single year. Okay, let's now get to actual on-site. First round of design judging, everyone goes through it. And the way we organize it on our end is each queue of design judges, we have about 6 or 7 design judges in each queue, they will see about 8 cars each. If you're at the main competition, a few less than that at the smaller June competition, and they'll spend 1 hour judging each car. And the way that hour is split up, at first, students give about a 2 to 3 minute introduction. This is the hi, we're the school of whatever. This is our car. Give us a little bit of history. Maybe tell us, it's our 5th consecutive year of attending this competition. Last year we finished 23rd. This year our goal is da-da-da. And then, probably identify who the different leads are for the different subsystems. Then our judges pair up with the students and just have conversations. And if you look at the photo I've included, I've put stars on the 6 design judges I could find in this picture. There might be a 7th one hiding behind somebody there somewhere in this picture, but that's okay. The point here is that our judges split up to talk with the students, okay? And they're individually discussing whatever their area of expertise is in their subsystem. So you want to have students on your team who can talk separately to different subsystems. Okay, this should happen naturally, but we do see teams where, Joe did the chassis and Joe did the suspension and Joe did the aerodynamics and Joe did the engine. And then when that becomes a big problem when we get to design because Joe didn't share or there wasn't anybody else but Joe or whatever reason it happened that way, we can't all talk to Joe at the same time. So if you have an idea ahead of time, who's going to talk to who, roughly, that's good. Keep in mind that judges have the same kind of limitation that students have. You are unlikely to wear only one hat when you are designing and building a formula car. And among 6 judges, we could probably split the car into 12 different subsystems pretty easily. So our judges also have to cover multiple systems. So there's a little bit of give and take during the time that we talk with you. The person who's doing aerodynamics may also be doing ergonomics, for example. So can't spend the full time talking aero, got to do ergo as well. Okay. Your students, students on the team are probably gonna be in the same boat where you're gonna want to talk to a couple different judges. The judges will talk to you for about 45 minutes. That leaves the last 15 minutes for judges to sit down, write our notes together, discuss what we saw. We multitask furiously during those 15 minutes, trying to get as much information written down in the parts of the car that each of us saw, while also sharing experiences with the other judges and getting a feel for the entire team as a whole. Okay, so don't be surprised when judges stop talking with you after 45 minutes because they really do need that time, that 15 minutes to pull it all together and make sure that you're, what was seen and what interactions we had with you are recorded and, we have a good sense of what your car is like. Things to bring with you to first round judging is anything that can show what you did. Bring binders if you got printouts of different things or calculations, laptops if they're on laptop, to be able to show whatever it is, your simulation results or what have you. If you broke parts and learned something from it, and maybe your pick something, your suspension, sphericals, somehow you failed one in testing. Okay, show it to us. Say, here it is. This broke. We figured out why it did this, this, and this. The solution to that is this, and then we implemented it on the car, as you can see here. Okay, awesome. We love that kind of thing. Okay. Some people ask us, are display boards required? No, they're not required. And quite frankly, they're not even favored. Some teams have display boards, big poster board things they stick around the car, and maybe each one has a subsystem of plots on it. Keep in mind, we have seen your design briefing, and so many of those same pictures would be appearing on your design boards. Are they nice to point to on a design board? Sure, that's a plus of design boards. At the same time, they do make it a little bit harder to get around the car and to interact with students. We don't have a whole lot of room in our garages, so take the picture you have here and surround it with design boards, and you can see how it can get a bit cramped. So design boards are not a positive, they're not a negative. Whatever you feel is best, we're happy either way. Okay. Then more about the first round of judging. The actual conversations you have with design judges are just that. They're conversations. Okay, this is not a test. No one's there trying to poke holes in you. Nobody's there to, do anything more than hear about this amazing project that you did, learn what you did, try to guide you along a little bit during judging to get the information the judges need to assess how well you did. But mostly it's judges listening. We really, really want to hear about your work. Okay, we'll ask questions to learn more about your work. What doesn't happen is a lot of feedback during that 1 hour of first round judging. You'll get very, very little, quite frankly. And that's by design. Okay, we're here to intake information during that first round of judging. The feedback will come the following day, which we'll talk about on the following slide. Okay, so as the third bullet point says, we give you plenty of information, plenty of freedom to convey your information. We really want to hear your story. We're happy to follow your path, mostly. We'll, keep you between the wall and the grass if we have to ask questions, kind of guide you along. Sometimes students get a bit nervous, or they're tired, or they're not sure what we want to hear. And so, sometimes we have to guide it a little bit more than others, but one way or the other, we really want this to be your show, your thing. And at the same time, we want to get the information that we need to properly evaluate where you are in terms of your engineering design, your design process. You will have to defend your design decisions. We will ask questions like, well, why didn't you choose aluminum for this instead of steel? Okay. Did you consider that? Why did you make that choice? We'll poke things like that here and there to probe for your knowledge. But again, there's no check boxes. It's not a test. We're just trying to understand what you did and what you didn't do. What makes us happiest is when you complete the theory, design, build, validate, refine, and understand cycle. So you should start out with some idea of how the world works, theory, and then use that along with your constraints that you have to come up with a design. Then you build the thing. Then after you've built it, you should see if it works the way you think it did. Okay, whatever that means, whether it's individual testing of parts, testing the whole vehicle, you got to take some data somehow to see that it's doing what you think it did. And then the understanding part. Okay, we're perfectly happy with negative results in this entire process. A negative result is better than not finishing the process in the first place. So if you do your theory, design, build, and then test and realize, oh no, if I had a chance to start over, I would have done X differently. Okay, tell us why. All this, okay, good. Okay, that gets you lots of points in design. It may not help you when you drive the car because you obviously decided you've got something that you don't like, but in design, we're happy with that. Of course, we're happiest when you complete the whole cycle and it all comes together beautifully, but that's not the way engineering works consistently. So we're happy if you learn by completing the whole process. The next line is interesting. We always want to make sure that you tell us your whole story. Okay. One of the saddest things is when we get to the end and we think we're pulling in all the information that you want to give us, and then somebody's like, oh, but I never told you about my whiz-bang thing here that I did. And it's like, oh man, I wish you would have said something a little bit earlier, because we want to hear about it. So part of this interaction, this give and take that we do between students and judges, is to make sure that we cover the whole car. Judges do know to ask before it ends, hey, did we miss anything? Is there anything else on this car that is important that we should talk about? Because we really don't want to miss anything. And at the same time, it's up to students to point out the things that we may have missed. So we just want to cover the whole thing. Another note is that we judge the car of the team that is in front of us. Okay, so the students who are there in the garage during first round judging are the ones who we expect to have the knowledge and the understanding of the car as it is. Okay, every car has legacy parts, that's understood. But even if it is a legacy part, the people who are there now have to understand it as if they designed it, built it, tested it themselves. And that's just the kind of knowledge transfer that needs to happen. Yes, occasionally somebody gets sick. Occasionally somebody's on a job interview. Somebody's off to their dream job, can't make a competition. Well, that's unfortunate, but we still need to just judge the team, the car that's in front of us. Okay. The specific procedures at the very bottom. Cars must be weighed before you enter first round judging. If you show up without a weighed car, we will send you back to get it weighed, and that will just go against your time for first round judging. You don't have to have a completed car. It doesn't have to be a running car, but it should be presented as race ready as much as possible. And if it's going to be driving, we expect it to be fully race ready. Okay. Stick to the schedule. Like I mentioned, we will not give you extra time. Okay, if you're late, that's just time you could have been earning points talking to the judges. Okay, and first round judging is only for students who are on the team. So faculty and spectators are not permitted to interact with the process. And furthermore, as it's an in-person event, in-person participation is required, so we do not allow remote participation. Okay, a couple comments on the score sheet. Judges use a score sheet that's posted on FSAE Online to record their scores. A little bit about how this works, because if you haven't seen it before, it's maybe not as straightforward as you think. As you can see on the right, here's our top page. We've broken the entire car into some categories. These roughly align with the areas of expertise we would expect individual judges to have, although not completely. And so there are areas where we can then break the car down into various subscores. Whoever's assigning, whichever judge is assigning points to each of these areas will be using the full range of scores. So whoever amount of total points one area has, you can expect us to assign from a handful of points all the way up to the full amount, okay, and use the entire range. You know, we're not stuck in the very top little bit as if this was, 75% is failing or anything like that. You know, we use the whole range. It's there to use, so we use it. When you add up all the points on this sheet, the total you get at the end will not be the same as the score you receive for the event. One of the biggest tasks that us chief design judges have is to take the scores from all the different cues and to do some normalizing, to do some binning, to do some scaling, etc., to make the scores as fair as we possibly can across the entire competition. We understand that every judging queue has its own personality at some level, even though they have the same marching orders and the same set of criteria to look at. They're also different people, and so it'll come out a little different. And we can see that often statistically in the different queues that we have. We also talk with all the individual queue leaders and the judges in the queues on the way to making our decisions as to what the actual score is for those who are not making design finals. And then, we'll talk about finals in a moment, but we have a really good discussion about who makes design finals. The score sheet itself, please keep in mind, is not a checklist. You'll see on the next page a detailed sheet from one of those categories. There's a whole bunch of individual items on there that are there for guidance for the students, things that you might want to know about, the kinds of things that judges would be asking you about or interested in hearing about. So it's not a checklist. This is not a test again, it's a conversation, but these are the topics that, would be in the conversation. Idea being, if we don't tell you, then how are you going to know? We'd rather not you spend a year trying to figure out what kinds of things we're interested in. We should just tell you up front and see where you go with it. This score sheet is also handed to you at the end of the feedback session. So here's the feedback session. Picture on the bottom shows roughly what it looks like, where you have judges on Friday, maybe Saturday, coming back to visit you in your paddock. Team kind of hangs around, we hang around, and in the course of 15 to 30 minutes, we look at our hastily written notes on our design score sheet, and we comment on them back to you. tell you things we liked, tell you things we didn't like, open doors to the next steps for you, give you suggestions for how to improve on things, thumbs up when you do a really good job on different parts. You know, we want this to be both positive and negative comments in our feedback. You also get to take the score sheet home with you, so you have a written record of the comments that we give. That's something you want to look back at throughout the time between competitions. Just like the first round of judging is a conversation, this is also a discussion, but this is a much more open discussion. Okay, here we're not just listening mostly and asking questions, it's clearly open two-way street. So if you have questions during a feedback session, you know, go for it, we'll answer them. We can clarify things that maybe you didn't understand when we asked you a question about something in first round judging. You say, well, you asked me this, I didn't know what you meant. Okay, well, we'll tell you what we meant. We'll just explain it. Or if you had an idea of, I was thinking of doing it this way instead, what do you think? Well, we could say, well, okay, here's my opinion. Okay, so that's the kind of thing we want to accomplish in the feedback sessions. And I can tell you that almost to a person, the design feedback is the favorite part of the event for all the design judges, because that's when we really get to share our own experiences, our own talents with you. And, you know, we're just as excited about this stuff as you are. We're just a little bit older, right? So it's great to be able to share that with all the students. Design finals. Okay, about 10% of the field makes it to design finals. This is held on a Friday evening, roughly 2.5 hours long. And the selection process is an interesting one where all the judges get together. It starts with the score sheets, and there's quite a bit of discussion before we decide who are the finalists at any given event. Okay, there have been in the past rumors about, you know, there can only be one team per queue, or it has to be a certain number of teams. Honestly, there's none of that. It's just whatever teams are the most worthy, according to our judging and our discussions, those are the ones that go. It doesn't matter what queue they were in, how many, if we send 10, 12, 8, 6, you know, it's entirely up to just how it falls that particular year. In finals judging, the teams stay stationary in the garage and judges rotate through every team. They tend to ask the same line of questions, and judges ahead of time agree on what specific area they're going to go into depth on, so that we're not covering, you know, the same pieces of the car 2 or 3 times. When I say go into depth, in finals, we go into depth. Okay, so we will ask you questions deeper to assess just how far you can go. And so if you go into the finals thinking, okay, I am going to get stuck, likely, don't worry about it. Okay, we'll push you down, we'll dig as deep as you can go, and then we'll say, okay, thank you. Okay, that's good. Then we'll compare how deep everybody went, score accordingly, and in the end, we'll have the finals with their scores. Okay. Just like in first round judging, you want to show up with your notebooks, your laptops, etc., anything that can support the work you've done. You know, we much prefer being able to look at plots and graphs and data or calculations instead of just a bunch of, you know, heuristic, oh, I think this is better. That usually doesn't go very far. Okay, so with that, I don't think we have any questions yet. And so I will turn over the next part of the presentation to Bill Riley. And he's going to start talking about design considerations. All right, go for it, Bill.
Great, well, thanks for that. And we're going to now segue into talking about some design considerations, which is more about designing the car and how the car should look. So where do we start in this whole design process? Well, we start with the rules. The rules are very fundamental. The car actually, you know, obviously has to be designed to perform the things laid out in the rules. We, as the rules committee, has spelled out the different dynamic competitions, the static events, so it's very important to key the car to the rules. Next, the tires. The tires gives us our interface between the vehicle and the ground, and so it's very important to start with the tires and work our way into the car. Next, we need to look at the score rubric and make sure we understand how points are assigned. Point sensitivity analysis is generally a great idea to make sure you understand how vehicle performance and decision makings tie back to the score in the different events. And lastly, you want to keep track of lessons learned over the years for your team and make sure you're learning from those. For example, I once sadly saw a team that didn't put a flange on their intake manifold, and that it separated during endurance, and they went out and they somehow lost track of this, ended up using the same exact um, posts that didn't have the barb on it the next year, and they went out twice in consecutive years for the same reason. So that was very sad. So then on a per event basis, what are your goals? So like, again, like Edward said, it's you lay out what your goals are. If your goal is to win acceleration, is it to win overall? You need to design the car to meet your goals. And then essentially take your goals and develop a performance spec that will meet them. Break the car down into systems and work your way down. This is all pretty basic systems engineering. Make sure that the big picture is in your mind and it overrides all else. So it's all about compromise and balancing different parameters in the vehicle design process. You need to also work a vehicle layout. So that includes things like the mass of the parts, the center of gravity of the car. Mass and center of gravity, these things are very fundamental to the performance of the car, and they're very fundamental to the way you will talk to the design judges about your car. So really having a tight story there and tracking mass and CG over the course of the design process. It's not just you end up with, it's the thing that you monitor and you actively work and try to get the best outcome. There's also a synthesis component where every component and its interactions needs to be considered. For example, if you put the radiator in the back, maybe you help adding weight to the rear if that's your goal, but then it's like could be shrouded by the roll hoop or bodywork. So everything has an interaction effect that has to be considered. And you have to iterate through these system integration issues, always keeping in mind weight distribution and CG. So some other important considerations, there's always the keep it simple approach, which has a lot of merit, especially if you're a new or developing team. You want to kind of scope for success in terms of what you bite off. And then there's also high tech. So you always need to look at these things through the lens of, I would go back to the point sensitivity and understanding, like basically if you're trying to win, then does this component that you might add, does it help you enough to pay for the human investment in time and bandwidth from the team members, the price and the cost report, and all these different factors. The tire data from the FSAE Tire Test Consortium is so fundamental. We think all teams should really have access to that. It's a great value to have all great data available to you in designing your vehicle. It's really a must-have, I think. In terms of data acquisition, it's both an engineering tool and a driver tool. I'd say it goes both ways too, where the driver feedback, use the driver's head and their senses to give you data, but you also want to have the electronic systems in place on the vehicle to be able to quantify some of those different things. Mass versus stiffness, when you're talking to the chassis judge, you may talk about how stiff is your tub or how stiff is your frame. These things are always trade-offs and a balancing act. So you need to be able to figure out how stiff is stiff enough. Gasoline, it's like different octane ratings. It's like, well, there's different engineering attributes to these fuels, like the latent heat of vaporization. So you need to make good calls there. There's also these itty bitty parts. Basically, if you take mass out, they'll be lighter. That's obviously great until you compromise reliability. And then there's also other decisions like carbon fiber. It's cool, obviously, Formula One teams are using it, but you need to decide what's right for your team in terms of cost, complexity. And then lastly, modeling and analysis versus physical testing. We really look to see the whole process laid out, where you start with kind of rough concepts, design schematics, you start modeling, you do analysis, and then you validate and verify that through physical testing. So we expect to see that process for each of the different decisions in the vehicle. And really, if you look again at the score sheet, you'll see that we're there to try to give you points. And so making a case of how you've done modeling analysis and physical testing will really help with how you score. Okay, so here's a few slides that compare and contrast different approaches. And again, there's really not a right or wrong approach. There's the approach that is systemic, integrated with your design values, goals, and approach. So here we have two different suspension designs. The one on the left is an old Wollongong car that has a pretty complex suspension system. And then the one on the right has a pretty traditional inboard rocker suspension. There's going to be performance gains, cost gains, mass trade-offs in both of these designs, and both of them can work great. Both of them can lead to a winning car. Yeah, that the one on the left was a hydraulic suspension. It had a like fore and aft communication between the different systems to give them a what they perceive to be an advantage. But again, it's like you need to fit these things into your car and your car design. In terms of aerodynamics, it's really important to consider a few different things about aero. So the time and the expense to build and design it versus the real benefits. We do see a ton of benefit from aero. So we're not here saying um, that aero can't be great. It's just it does take time to develop. It's going to add mass to your car, and the competition benefit is going to be essentially your time around the lap is going to be faster. So what we're really looking for when we're talking about aero is to be able to justify your choices. So that means a car that doesn't have wings should be able to speak to what would their lap times have been like if they had included wings, what would be the mass change, and then talk to us about why you decided not to. Maybe you didn't have bandwidth or team member expertise or something, but you can't show up with wings or without wings and expect to, it's not a checklist where it's like, okay, you have wings, so you get points. It's like you have to like, be able to explain your decisions and talk us through how you've engineered these different systems, whether that is you've engineered it to not have wings or you've engineered it to have wings. When it comes to composites, in this case, we're comparing and contrasting a steel space frame with a carbon fiber monocoque. It has really essentially the same elements we were just talking about. There's time and expense to design and build it, but there's also real benefits. For example, it's likely to be much stiffer. You might have an easier time passing the structural equivalency. You might not. You might have an easier time with kind of the baseline steel frame. You might have the ability to analyze the composite monocoque, or you might not. There's all these different factors you need to weigh in your decision making, and there's really not a right choice. Again, we've had design finalists. We often have a few with carbon monocoques and a few with steel space frames. The composites are process sensitive. You need to allow time to build it. We see a lot of teams who have issues. It takes experience to build these parts. So you don't want to wait to the last minute. You want to allow time to build it twice. And then when problems are found, what's plan B? It's not enough to know how to make the monocoque or weld the frame. When you have an issue or someone gouges the tub, do you know how to repair it? So there's a lot to think about when making these decisions. Here's some qualitative design rules to keep in mind. Not so much rules, of course, but just kind of good guidance. We always say if it looks right, it might be right, but if it looks wrong, it probably is wrong. So just keep in mind that we have a limited amount of time with you, and we also think there's like sort of an aesthetic to good design. And so when we approach your cars and look at them, we look at your design reports, we're really looking to see excellent engineering. Those things manifest themselves, for example, as good load paths. Good load paths um, are very fundamental. Bending is terrible. You really want tension and compression load paths. That leads to triangles or tetrahedrons for space frames. For suspension elements, you want to, again, avoid bending and have, very low distance. It's free in the cost report. It can't break. No one has to build it. So you really need to make sure you're trading off the performance the parts bring you with the risk that they also bring. Formula SAE fundamentally, as much as we love design and talking about design, it's a project management exercise and a systems engineering challenge. So make sure you have good systems engineering. That means it's as simple as team members talking to each other, sitting next to each other when they are designing parts. So you want the chassis person and the suspension person to really sit together. We can walk up to a car and tell when they didn't communicate, and the suspension punches into a point in space that's very far from the structure. So make sure you're doing the very fundamental systems engineering things like communication. You can also get fancier, of course. Just make sure you emphasize that in your project team. When it comes to train development, make sure you have the right spark timing. It's very fundamental, and we see teams that are struggling with that and the cars don't run well. And before you get fancy, make sure again you have the fundamentals right. It's so important for engine performance. And then one of our sayings is, again, mass begets mass. So as your car gets heavier, your suspension has to get heavier to take the loads, wheel centers have to get heavier, everything gets heavier. So you want to have this positive feedback loop where you're able to take weight out of each and every system, which will then allow you to take weight out of neighboring and adjacent systems. So really focus again on low mass and getting the right CG. And obviously the one downside here is if it's too light, it can break. But again, if it's that attention to detail, it's not brilliant design. It's sort of make sure things are tidy, that there's no bending, and that you have a real focus on low mass. All right, with that, Tony's going to take over.
Thanks, Bill. So yeah, I'm going to talk briefly about, just generally a number of things. There's definitely some overlap with the section that Bill just covered, but I think this overlap is somewhat intentional in that realistically these things are pretty important, and we want to make sure that that the messages are kind of driven home. So this first slide here, there's a number of things to think about and be continually asking yourself throughout all phases of the design. Quite literally, this is as you're designing the car, thinking through these things, as you're building the car, as you're testing the car, as you're polishing the car, just continually be asking yourself these things and kind of hopefully iterating. And that along the way, hopefully, there'll be a couple of things that pop up that you can, further design, make some tweaks and some changes that overall result in a better overall project. First off, does the car look like it was designed with the systems focus? This one actually ties in, pretty closely with the next item, that being, what parts look like they're afterthoughts, and honestly ask yourself, were they? Often there's situations where you've got like two brackets that are basically touching each other, doing two different tasks, where if you were to step back and thought about it a little bit more, could you build one bracket that supported both parts, nice and cleanly, one less part to make, fewer fasteners to assemble, possibly, lighter weight, just continually be thinking about the overall vehicle as a system, and, assessing the bits and pieces, not only on their own merits, but as they interact with, the rest of the vehicle. Packaging, is the packaging tidy and look planned? It really is pretty amazing that the best cars literally look like they have about half the number of parts on them as some of the the more, I guess, struggling cars. And this is not by accident. Everything really should have its place. And again, this also kind of ties back into, are you designing things with a systems focus, thinking about the holistic vehicle, not just breaking everything up into its individual parts, everybody running off in their own directions and doing their design work and then coming back together to bolt their stuff together. Ideally, the teams are working truly as teams with the team project managers and chief engineers and whoever, really, ensuring that there's good communication, and that, the vehicle is worked on holistically. Are items such as wiring, is it exposed or is it, neatly routed? Time and time again, we walk up to a car during design judging and we just see, a bunch of wires just running everywhere, zip tied to whatever it can closely be zip tied to. Sometimes not even that. Sometimes it's just a big rat's nest full of wires. Obviously those are extreme examples, but again, it's just, it's super important to try to ensure that not only, is everything nice and tidy, but there's also, reliability and serviceability and other aspects there that just come along with having like a nice, wire loom. Like if you have to, disconnect, if you have to remove the harness, it's much easier to remove a harness just by unclipping all of the connectors and lifting it out of the way than it is to have to separately, pull a bunch of different wires and whatever, snaking them, up and around and what have you. So, be cognizant of that, and thinking about, again, how does the whole overall project look? Are components adequately protected from the environment? Time and time again, we see, parts kind of being put in harm's way. while, you know, hitting a cone is unlikely to damage a brake line, why subject it? You know, why run that test? Just put the brake lines on, you know, on the backside of the control arms. You know, wires, often you'll have a hole, you know, running through a carbon fiber panel. You know, really holes, if you're a wire, a hole looks like a saw. You know, you want to make sure that, you know, you've got, you know, any harnessing and that kind of thing well protected, you know, both with you know, over wraps, as well as, you know, grommets if possible. You want to make sure that, you know, that you know, any wiring is crossing, you know, friendly surfaces as opposed to, you know, sharp edges. Maintain, you know, maintenance and adjustability. You know, I mean, in any race car is going to need some level of adjustments, and, you know, knowing, you know, you should just know that going in and plan for that. You know, ideally you're able to make adjustments very, very quickly, very, very precisely. You know, a lot of teams do stuff like using, you know, like say for adjusting camber, they've got, you know, a kit with different size shims. You know, the green one, they know that is 0.1 degrees, a blue one that is 0.2 degrees, you know, and so on. So they can, you know, if they want to make a quick adjustment on the track, they can just do it. You know, literally the car rolls in, loosen a couple of bolts, swap out some shims, you know, and they don't have to rescale the car. They don't have to, you know, balance quarter weights. They don't have to measure. They just know. Same goes with, you know, like for example, making shock adjustments. You know, are the adjustments, you know, points where you can easily access them? Do you have to jack the car up in order to, you know, put in 2 more clicks of rebound? I hope not. Hopefully you can just reach down and do it. Or maybe you've got just a simple little cover plate that you can pop off and adjust. Things like changing the oil. You know, I was part of a team that in order to change the oil filter, we had to remove the header from the car. I mean, that is clearly undesirable. You know, if you're working on your car at home and, you know, you wanted to change the oil and you had to pull the exhaust manifold off, you'd probably be pretty pissed about that. So ideally, again, we're thinking about these things not only as we're doing the initial design, but as we're building the car, and, you know, and again, iterating through and just seeing, is there something I can do now to make this situation better? Is there something I can do now to make the car better, more reliable, easier to adjust, easier to maintain, what have you? The next one here, this does apply mostly during the, you know, the build phase. But is the car on track to mass? Is it CG where you expect it to be? Or are things packaging correctly? I highly recommend teams, you know, using, you know, having a spreadsheet as they're building their car up, you know, having a fish scale, you know, so they can weigh every single part before it goes on the car, you know, trying to maybe take some, like, you know, little estimations as to where the CG of the parts are. And again, just make sure that you're tracking to your overall design goals. It could very well be that you have to make some adjustments. You know, it could be, you know, say there's a component that, say the radiator comes in and it's a pound heavier than you expected it to be, and the radiator sits on one side of the car. It's like, okay, if the radiator's heavier than I expected it to be, what can I do to get the CG back where I want it to be? You know, is there something I can shift a little bit? You know, can I shift the radiator inboard? Can I move something a little bit farther outboard on the other side? You know, what can I do in order to just maintain the center gravity targets? This is especially notable. You know, this is one of the reasons why we do insist that the cars are weighed before competition or before the design event. You know, you will note that on the weight sticker, in addition to the, you know, the dry weight, we also have a percent front and a percent left weight, and those are to help us understand how did you do in that regard. I mean, for a open wheel, you know, formula, you know, for an autocross style car, you know, there isn't much of a reason to have a heavy, you know, left versus right, you know, weight bias. If we're talking a roundy round car, that'd be a whole different animal. But, you know, if you ended up with a 54%, you know, left weight distribution, something probably went wrong, and we're probably going to ask you about it. You know, likewise, if you're 60% front weight distribution, that probably wasn't your target. What was your target? And, you know, we're probably going to be wanting to talk to you a little bit about, you know, what are the implications of that? Ideally, you're able to make some of those corrections as you're building the car, because if you don't, it's going to make tuning of the car significantly harder. Just again, because you designed it to be a certain way, you sized your springs, your roll bars, your dampers, and all of the bits and pieces, aero, for a specific center of gravity. And if it's not where you designed it to be, you're going to have to compensate for that in some way in order to basically get back the performance that you've probably given up. Tuning, again, it goes back to, can you easily make precise changes? Changes that what they are and that you can predict what the expected outcome is going to be from that. Again, it's ideally these are things that are making your testing time, your very, very valuable testing time, as beneficial as possible, not only in terms of just not wasting time to do to make a change that is that could be easy, but also to ensure that you're getting the outcomes that you expect. Because again, if you go to make a camber change and it turns out you actually it's about 1-for-1, you change camber, you also change caster, the resulting vehicle performance is going to be different than you might have otherwise expected. So again, targeting easy to make tuning changes, as well as ideally discrete adjustments. Here's a couple of examples. Again, this kind of reiterating some of the earlier points. Obviously this is it's not a very clean implementation here. Not only does it just look messy, but there's absolutely going to be some reliability issues that result of this. I know which car I'd rather work on. Or I guess the next slide kind of gives me the what I'd prefer. But as you can see here, not only is it just it doesn't resemble a professional effort, which again, that is also an important aspect for Formula SAE designs. But ultimately, this slide is more about trying to protect you guys from yourselves, and making sure that you're building something that you can have fun with and go do your testing and development without just hassles. If we go to the next example as a contrasting, it's pretty amazing just how clean some of the well done cars are. Everything has its place. Everything is super well integrated. And again, if you were to look at these cars versus some others, you'd almost think that they had half the parts in them that the other ones do. And I think and that takes a lot of effort. It's one of those things where it's hard to make simple, elegant design is hard, and it takes time. But if you look at just how beautiful some of the well done cars are, I think it's hard to argue that it isn't worth it. Details. As in engineers, we definitely tend to be rather detail oriented, and focus on some of the little things. We hopefully not missing the big things, but we definitely hone in and tend to nitpick. But again, a lot of these are things that you can really fix, as you go. These are not things that, I messed this up on day one of design, now I have to live with it for the rest of the build. It's like, no, a lot of these types of things are things that you can literally fix at competition the morning before design. I'm not encouraging that you do that by any means. I'm just, the point being that there is always time to take care of some of these things. It's never too late. Again, just to be a little more specific, we've got, brake lines, the wiring, just, making sure things just look clean, are protected, watching out for function, things like, again, if you've got, wiring harness that runs out to a wheel speed sensor, did you give it a little bit of a strain relief? Does it have a little bit of a loop so that as the suspension moves, you're not pulling, you're not, treating that harness as a tension element. Same goes for the brake lines. Do you have full, can you go from lock to lock on steering without pulling the brake line tight? Or having, basically having to fight the brake line. Ultimately, you want a car to look like, again, getting back to, it looks as simple as it could possibly be, because you've basically done the effort to simplify and and get an elegant design. Extra threads, obviously, playing with wheel offset, spacing, that is absolutely a knob for tuning, no question. However, by the time you get to the competition, hopefully, whether or not you need all that extra, thread, like on your wheel hubs. And logic would say that you're probably not going to be putting 2 inches of wheel spacers on your car. If you did, you may want to be, rethinking some other components. And this is common, the wheel spacers are an obvious one. But time and time again, we see, just suspension link, bolts that are like, an inch longer than they need to be, and like this, and we understand that, that some of these bolts are expensive, especially if you're getting, NES fasteners, aircraft, fasteners or whatever, and if you can't get the right bolt, you don't have the right bolt, you can always cut off the unnecessary threads, and just, again, tidy things up. It'll save you a little bit of mass. Every little bit counts. And it'll ultimately just look like a much more professional, installation. Again, reiterating the time, again, admitting that it does take time to iterate through and take care of all these details, but I absolutely believe that it is worth your efforts. Wing mounts. Again, the goal here, you want them stiff, you want them, strong enough to do the job. You want the aero elements to be where you expect them to be. Time and time again, we see, especially rear wings, kind of just bobbing all over the place as cars are running around the track. Clearly, they're not able to put their best, the best effort forward in terms of providing the downforce that you designed them to provide. If they're flopping around, cone strikes are a real thing. So make sure that, that your front wing, which is, generally the item that's in, the most amount of, harm's way in terms of whacking stuff, make sure that it's up for the task, make sure that you've designed it to be able to take that without, incurring damage. Same goes with some of the adjustability elements. Ideally you've got positive locating elements, not just a simple, loosen the bolt and slide the wings up and down for, angle of attack. It's easy. But if once you factor in the vibration and hitting cones and that kind of a thing, if you can lose, 2 or 3 degrees of wing angle just by driving around, that's definitely bad. So definitely give, crisp, clean, adjustments, a good thought. Likewise, ideally you're able to make very quick adjustments without having to put the car on a level. If you wanted to add, 2 more degrees of flap, ideally you've got a holes marked out so you can add 2 degrees of flap, without having to, again, get out a level and try to dial it in. I think that's everything for that one. Testing and development, we call it the design competition. Ultimately, it is a lot more than just the design competition, though. I mean, we want to be talking about, the fundamentals, and the foundational physics that lead to your design. We want to talk through the build process. Absolutely want to talk through your testing and validation efforts. We want to learn what you learned. And quite often, as Edward had noted, there's situations where you have maybe a disappointing outcome, during some testing, but you learn from that. And if you can, take that disappointing outcome, learn from it, iterate your design, refine your design, and make something better than what you had initially started, that's worth points. I mean, that's a valuable, that's a valuable piece of this whole thing. And ultimately what we want you to be able to understand and get out of this experience is, learning how to kind of run through the full process and go from, hey, I have an idea, to this thing freaking works. I can prove that it works. And, let's go win some competitions. Talking about the testing. This is where it's, some discipline definitely provides some value. I know, a number of teams we just want to go drive, we're going to go drive. But realistically, some planning will provide a lot of benefit. Every test should start off with a setup sheet. My forays, it's a little bit of professional motorsports. It's like, the car never left the paddock without having, the setup sheet completed with every shock setting, corner weights, what springs are in the car, what are the stab bar settings, what are the tire pressures, what are the, you name it. All of the information that basically defines what that vehicle is on a setup sheet. And that's basically the starting point that you use to iterate from. You should have a packing list. Nothing sucks more than you're out on the track, getting ready to go. And then all of a sudden it's like, oh, I don't have the laptop, or I don't have the cable to plug into to the deck, or we don't have we forgot this, the camber shims or whatever it is. Have a very detailed packing list. And I'd recommend even having, designating somebody to be, they are like responsible, for ensuring that everything is checked off. Next is a test plan. Again, testing time is generally pretty precious, especially for the teams in the Midwest where it's cold out now, right? It's hard to do useful testing this time of year. So you need to make the most of the test time you have, and that involves having a plan. What is it you're looking to test on a given day? Who is responsible for doing what? Ideally, you've got some baseline data, and sometimes that involves going out and setting a baseline lap before you make changes. And sometimes it's having a very, very specific course that you always run, and that what the lap times should be, what the data should look like. And you're using that for your development comparisons. Vehicle changes. You should know how you're going to do what, not only what you're going to do, but how you're going to accomplish it. And then lastly, what is the criteria for evaluation? Is it simply just the stopwatch? Is it the driver's opinions? Which, given that we're probably not, hopefully not dealing with professional drivers here, the subjective stuff is going to be a little tough to work through. Useful, but ideally you've got some very specific criteria that you're using to help inform whether the changes that you made were good or whether they were bad. Ideally, your teams are running a lot of data acquisition, and you've got, actual hard data to work from. And again, make decisions, which would then set off your next step. Data organization and management. Again, it's very, very easy to collect a lot of data. You can run around for, you can collect gigabytes of data pretty quickly. But then you need to do something useful with it. So you need to have a plan as who's downloading it, how are we going to analyze it? Again, especially if you're trying to use that data to make real-time tuning decisions, you really kind of need to have a plan, and be ready to execute it. And then after a test session, there's a data review, piece of this. Hopefully that also includes some driver impressions. That includes maybe even a debrief on the overall test session itself as to, hey, what didn't work this time? What did we not have in our packing list that we need to add? Was there a person that we, do we need more people to shag cones? Do we need more people to set stuff up? Do we have all the tools we need? Just again, think through, just to ensure that the next test session that you do is more beneficial than the last. Some overall, some final thoughts here. Again, fundamentals are critical. We really do want to try to drive all of the design decisions back to first principles, and try to ask the but why questions, to yourselves, to ensure that you actually do understand those basics. Legacy designs, purchase parts. You don't have to design every single part on the car, and it's totally fine to have, a part that was designed, last year. It worked amazing. It was great. We're just gonna, in the interest of simplicity and, why make it, why start over again? You reuse it. That, those are all fine. However, it is expected that in the design tent, when you're talking about those parts or those systems, that somebody there understands them and can talk to them as if they designed them themselves. Again, this all comes back to the justification. Nothing should be on the car that cannot be justified being on the car, and you need to be able to justify it with, again, engineering based rationale. Driver interface. We see a number of cockpits where the driver's kind of flopping around a little bit, or pedals are really tiny and they're having to search a little bit to find the pedals. Shifter efforts high, shifter efforts low, shifters that are really compliant, floppy, steering compliance, steering friction. Make sure that the driver interface is very good. I mean, in order to pilot a vehicle well, the driver needs to basically be well supported and effectively in a position where they're not having to hold on. The vehicle is holding on to them. All they have to do is to control the vehicle, and ideally with the cleanest inputs possible. And by clean inputs, I mean a lot of precision. You don't have friction masking steering inputs, or the signal from the contact patch is able to make it up through the steering system, through the steering wheel to the driver. Pedals efforts are appropriate, travels are appropriate. You don't have a super low effort, super sensitive throttle pedal. You need some throw. You need some force to work against. Same for the brakes. Threads, wiring, plumbing. Again, make sure that all those details are being covered. Good fasteners with the right lengths. Wiring clean, plumbing, make sure it's routed in the right places, make sure you're using the right types of fittings and that kind of a thing for reliability. Make sure you're using the right, tooling for the plumbing fittings so we're not damaging them. Suspension kinematics. A number of teams show up with suspensions that are just so stiff, they're effectively a structure. And it's honestly, it's kind of frustrating in that, we stipulate in the rules that you basically cannot build a go-kart. You have to have suspension travel and all that, which ultimately should be for the betterment of lap times. So make sure as you're tuning the vehicle that you're working the kinematics, to develop a system that works very well. Obviously, if you lock the system out, I guess it can't do bad things, but it also can't do the good things that it's designed to do. Couple of just baseline data points here. The average last year car was around 476 pounds, around 216 kilograms. This kind of just gives you kind of a baseline. We have a semi hard written rule, soft medium rule, I guess, that cars over 500 pounds do not make it to design finals. There are clearly some exceptions to that, but we feel that a good car really should be very, very doable for well under 500 pounds. On the lower end, we saw the lightest car was 354 pounds. We do see cars, pushing, 300 pounds, from time to time. It can be done. However, we have also seen a lot of those very, very light cars have poor-ish reliability in the endurance event. So, again, the car to finish first, you first must finish. It does definitely applies here. So as you're making as you're doing design, make sure that you are applying the right types of margins for strength-based aspects. Mass and inertia have first order effects on vehicle performance. I think we covered center of gravity, being lightweight, several times through this, and that's for a very, very, very good reason. It is a first order effect. I think there's no questioning that. Ideally, you're also taking a holistic approach to weight reduction. The last thing you want to do is have one team or one subsystem team taking every single component to within a milligram of failure, and then you got somebody else sitting on 10 kilograms of fat. It needs to be a whole team talking through the systems together approach. Likewise, again, if you can have one bracket that does multiple, kind of supports multiple parts, why wouldn't you? Look for the overall simplest designs, and those will often lead to, a more mass efficient design. And then lastly, validation. Validation is essential not only to your learning, not only to ground your models, not only to help you tune the vehicle, but ultimately it's going to result in better reliability. It breaks my heart. Every year we see teams not finish endurance, and knowing how much effort goes into building these cars, it just breaks my heart to see it. And more often than not, more testing and validation will have prevented the failure that they experienced. Not in every time, the racing gods, have their say from time to time, so it goes. But the more you test and validate your designs, you are significantly improving, your odds of success, in the competition.
Hey, Tony, we have one comment that appeared in the chat. It says, remember that not all data comes from the data acquisition system. There is lots of other important data like tire temperatures, pressures, driver feedback, lap times, segment times. You want to comment on that just for a moment?
Yeah. Again, we've, data, people will often, one of the first things they do is, jump right to the, download the data. But yes, all sorts of sources of data, it can, the little list there is pretty useful. Tire temps are an absolute must, if you ask me, for looking at how well is the suspension working, the overall vehicle setup. Obviously if the outsides of your tires are 15 degrees hotter than the insides of your tires, something's probably not right there. You're at least not using the whole tire as you should. Driver feedback, it kind of goes, the list is pretty self-explanatory. I'm trying to think of anything else that might be missing.
Yeah, I think the key there, Tony, is to have a method to combine whatever data file your data acquisition generated with these other sources of input in some coherent way that you can find them later and make sense of them.
Yeah, and I guess also worth noting your setup sheet. Outside temperatures absolutely should play a role here. If it's a really hot day, you should know what the outside temperature is. For example, going to mid-Ohio, if it's a hot day, I know that a car is going to be, we're talking like a Formula Continental F2000. It's going to be it's going to have a greater tendency to have a lot of understeer, to push. So I'm probably going to make some suspension adjustments to account for that. Or likewise, if I'm looking at the setup from last year's event at a given track, and I noticed, hey, it was blazing hot, or it was super cold. Okay, I'm going to take that as additional data, and I'm going to use that to kind of temper what I'm going to do next, inform what I'm going to do next, or help use that to try to explain the performance behaviors that I was seeing.
Indeed. So if you have any questions, please throw them in the chat. While you're thinking about your last chance at asking questions, I will take this opportunity to remind you that we have other virtual events coming up. They're listed at saedetroit.org webpage. You can go there and click on the register button. As you can see, there's one on December 1st and December 8th, and then a couple scheduled for next year. Since we don't have any questions in the chat right now, I have one for you, Bill and Tony, and I may have two of them, but we'll do one at a time. The first one is short answer. Like, what is something that commonly goes wrong for students in the design event? What's a failure point for the students that trips them up?
I think that one thing that I would just mention is maybe it's not a failure point. It's that I do see teams who leave and they feel like, oh, I wish I had said that one thing, which I think Tony mentioned. But I would say if you're really proud of a specific aspect of your vehicle, make sure it's on your talking points and you get to say it, because you don't want to walk away with remorse on having missed something.
Yeah, absolutely. Tony, what do you think?
Yeah, I think, one of the things that really jumps to mind is, well, two things. One, most of the data being in too few people's heads. Ultimately we do have to divide up into different systems and have, multiple conversations simultaneously. So if it's just the one person that has all the information, that just does not work well. And honestly, it's not great for the team either, because the team, I mean, you want to share the information with the team so the team can do more useful things and can work together better, I guess. And then the other thing would be oh yeah, that person isn't here, and then you just don't have an answer. And while it's somewhat understandable, I do not believe that it is all excusable. I think, before you guys, go to competition, conversations should be had, and a plan for who's going to cover what, and kind of just walk through the vehicle. And there should be somebody who is, if not the original designer, at least somebody who was delegated to cover something, and then it is their responsibility to get up to speed with it, at least to a certain level. Maybe not everybody can, understand the things as well as if they designed it themselves, but they can sure as heck have a pretty good understanding for why it is the way it is and why the decisions were made to use a given component or go with, with a certain solution.
All right,
Sure.
we do have
And
another
Bill,
question.
before you jump into that one, I'd like to answer my own question, which is to say, as much as we emphasize that this is not motorsports, this is education first and foremost, one of the main pieces of advice for motorsports definitely applies here in the design event, and that's don't beat yourself. One of the best things you can do is control all the things you can control, and that includes just being on time with deadlines, planning ahead. You have complete control over how much time you have for many of these things, and if you control those things that you can control, then you eliminate the beating yourself part, and then it's just, your best foot can come forward. So we so often see teams that, if they only had their act more together in some way, we think there's something there, but we can't get to it because there's these other things in the way. So that would be my answer to my own question. Bill, you had something?
Yeah, we had another question in the chat. It says, what do you recommend for lap simulations when the team is not so experienced in coding, while commercial lap time simulations also lack accurate kinematics?
Tony, do you want to touch this one, or should I?
Well, I'll jump in, and you can maybe finish it off. I mean, ultimately, this is one of those. It depends on you. It depends on your team and your own situation. It's also, lap time simulations are also very much a thing where, all models are wrong. Some are useful. So I guess it's going to come down to what is it that you care about the most in terms of, what are you trying to get from your lap time simulation? I mean, and agreed, in order to have accurate kinematics, and I would add and compliance to a simulation, it's going to have to be a pretty sophisticated, system. You can do some pretty useful stuff just with, some creativity and Excel. There are, some free lap sim tools out there. And there's some that are not free. And I don't know, I wish I had a better clean answer for you, but I think it just comes down to exercise some creativity and maybe just set reasonable expectations for what you want to try to get out of the lap sim.
Yeah, I'll extend the question to all kinds of prepackaged simulations, whether it's lap time simulations, kinematic simulations, engine flow simulations, FEA, CFD, you name it. If you're using a already written package, we would like you to understand as much as you can what the assumptions of that package are, what the capabilities of that package are, because all engineering models are constrained by assumptions. First of all, they have regions of applicability and regions where they are not applicable. They have things they can do and can't do. They have things that they assume away because the world is way too complicated a place to get it all in there. So we have to make some assumptions. How much assumptions happen will affect the kind of output you get. And sometimes you can make a whole bunch of assumptions and get a good output, and sometimes you can make a whole bunch of assumptions and get something that's completely nonsense. So the idea is to understand those kinds of trade-offs in whatever package it is. The advantage of programming it yourself is you are forced to run into all those things up front. You have to consider the constraints, you have to consider what assumptions you're building into your own packages. But the downside, of course, is that you're spending a lot of time developing a tool instead of using a tool. You learn different things from both approaches. Okay, there are disadvantages of both approaches. What we really don't want to see, though, is to have you use a prepackaged piece of software and you don't understand the assumptions, the limitations, the capabilities of that software. It's just garbage in, garbage out, because guaranteed you're getting garbage out if you don't understand those things. So I think it's another one where we probably don't spend enough time talking about the use of available simulation tools, but it goes both ways. Like most things here in design, unless you're violating a fundamental engineering principle, there is no right or wrong answer.
I do think maybe like the saying, don't let perfection, perfection is the enemy of good enough too. So like the simplest sim that gives you the results that you can use, or the thing you do have access to, and understanding it in detail, like Edward was saying, is worth a lot more than wishing you had the fancier, atoms model with all the full kinematics. It's like, well, at least a 1D point model in MATLAB that you wrote and really understand, and you can use to influence your designs is going to be more powerful.
Yeah, I've definitely seen some pretty terrible results come out of very complex atoms models, and I've seen some pretty good stuff come out of some pretty simple models. And I think one of the keys there is validating and trying to ground your models. And if you run some simple tests on your model that you can replicate in real life and the answers aren't the same, try to figure out why. You should be, there's got to be a reason. Understand why, so that when you do iterate and do more important work, you can trust the results.
And of course, we realize that as a student, you start out as a freshman, perhaps in Formula SAE, and you know a little bit. And the amount that you learn in 4 or 5 years of undergrad Formula SAE is monumental, but it's not the ultimate. I mean, we're still all learning, the 3 of us here. And that's going to continue on for hopefully a few more decades as we keep doing our thing. We're just a couple decades ahead of you at this point. And so we understand, we remember where we were, we realize how much we did not know back in the day. And we look at some of the students who are coming through now and we're like, man, they run circles around us, back compared to where we were back then. But at the same time, as we try to give you perspective, we try to bring you along, all the judges try to meet you where you are on your team, whether individually or as a team, and bring you up a level. I mean, that's our goal, but don't think you have to do absolutely everything. One of the things I think that is this simulation or data acquisition trap is, oh, I got to do the full on everything or else it's not good. It's like, no, just pick a level, start simple. Simple is better if you understand it. And even if you understand it and know what it can't do and why that's a limit for you, that's better than doing something complicated and just believing stuff that comes out because that's what I'm supposed to do. That's definitely not the way to go.
Yeah, honestly, one of the best ways to impress me is to do something scrappy and simple that is just, it's not how it's often done, that works. It's like, good job. Wow. And usually that one of the outcomes of that, or the implications there, is that you actually understand the fundamentals to the point where you can do the simple thing and get a good answer, as opposed to having to just blindly, put 50 different inputs into a model and hoping that the model is right. So I definitely try to reward people for doing the simple, scrappy thing that's clever, smart.
Like Tony, there's one example I love is when you put the little tufts of string on the wing with tape, and you drive the car and you get this like beautiful flow visualization, and you can see what's happening on the wing and where it's stalling. And that's, to me, like that's the validation that can come after the CFD. But if you say you don't have CFD, you can still do these very basic straight line testing things. And you don't want to miss those opportunities just because you don't have access to other aspects of it.
Yeah, I will buy you string and tape if you say your team can't afford it.
Okay, are there any other questions from the chat? I'll give you just a moment here if you type quickly. So we're about out of time. We'll need to wrap this up. All right, so I want to thank everyone for joining us in this design overview and asking your questions. Thanks for Tony and Bill for joining me today. It's been fun. Special thanks to the SAE Detroit section staff and the SAE Carolina section staff who were involved in putting this together. Really appreciate it. It went very nicely and smooth on our end. Any questions or inquiries about this presentation, please email the SAE Detroit section at events@saedetroit.org as shown on the screen. And finally, if you're watching this on YouTube, please consider liking this video, sharing it with someone who might find it useful, and subscribing to the SAE Detroit section YouTube channel. Everyone, take care. Thank you so much, and we'll see you at competition. Bye-bye.